Math 126 students, going to talk about pages 3 and 4 of your final. These are going to be likely about chapter 14. So I'm just going to say a few some general things. So first, I went through the 4 most recent finals and made some notes for myself. Winter 2022 is the most recent final in the archive. There was a partial derivative question that had some implicit. There was a global max and min question. Fall 2021, there was a find and classify critical points and a global max and min question and a partial derivative. Spring 2019, there was a find and classify critical points. It looks like we had more questions on chapter 15 that term. Winter 2019, there was a tangent plane. There was a find and classify critical points. Okay, so you can get a flavor. Your pages 3 and 4 will be similar in nature. So let's say some specific things. So what did we do in chapter 14? We studied surfaces. We learned some of the tools. This is from my review sheet, fact sheet. But ultimately it was about if someone gives you a surface, what can we say about it? And how can we analyze it? And we actually went in a little depth. We talked a tiny bit about contour maps, about, if someone gives you whatever it is, square root. I've had a few people ask me about this on the discussion board. A contour map in itself shouldn't scare you. Like if I said, what do you get when this is, what number should I use? 3, just as an example. No, 3 is bad. How about 1? You could say, what are all the things that are at a height of 1? It's just a visualization tool, and you rearrange, and you say, oh, the level curve is a circle of radius square root of 8. And we use that to graph and visualize a little bit. It's not that easy to ask questions about that, but it's a helpful visualization idea if you're trying to graph this thing. Because now we know that if you are 1 unit up, you just get a circle of radius square root of 8. And you could draw more contours to get a sense of what's going on. But at some point it became hard to visualize, and so we needed a calculus. And the main calculus tool was a slope in the x direction and a slope in the y direction. So we need to be really good with our partial derivatives. We just did this on exam 2, so maybe I won't say as much, but you need to know your partial derivatives well. We talked about interpreting what those are as a slope in the x and y direction. If you're standing on the surface and you look in the x direction, this is the x-axis, or you look in the y direction, this is the y-axis. We found those 2 slopes. You actually could get a vector in that direction, but we did not use that very much. We did use it to find the equation of the tangent plane, but once we have it, finding the tangent plane is fast. So a tangent plane question, you want that to be a gimme. You want it to be really easy. What do I mean by that? So let's just quickly, I'm making up an example on the fly. Here's the partial with respect to x. Here's the partial with respect to y. And so if the question said, what's the tangent plane when x is 1 and y is 2? You just plug these things in. It's super fast. So if you plug in 1 and 2 here, so it's going to be 8, 9. So I get z minus 9 is equal to, and then you plug in 1 and 2 here, 8, 16, plus 4, so it's 20. Apologies if any of these numbers are wrong. I'm just giving you the idea. And then you plug this in here. This is going to be 12 y minus 2. That's the tangent plane. So don't let a tangent plane question scare you. If the question asks for a tangent plane, that's it. If it asks for the linear approximation, all you do is move the 9 to the other side. If it asks you to use the linear approximation, you, at the very end, replace x and y with whatever they want you to use it at. So those are all what I would call fundamental ideas. We did find the second partials and we interpret them a little bit. It is nice to note that you can check your work on partial derivatives by computing the 2 mixed partials and see if they're the same. If you compute the partial of this with respect to y and the partial with respect to x and you don't get the same thing, then that means you screwed up your partial derivative somewhere. Okay, that was the first part, was we learned how to find slope and how to get some basic information about a surface. Then we used it. We focused on applications of critical points. So the big skill is solving system of equations, which isn't really a calculus skill, but that's something I talked about. I tried to help organize your thinking on how you solve system of equations. We talked about classifying critical points, which required you compute this D, and a lot of people did well on this on exam 2, so I'm not going to give a full review, but I would put the second derivative test on your note sheet. Remind yourself what has to be true. Then we did a global max and min, remember for those ones you basically have to set up what's happening over each boundary. It takes a little bit of work, but there's a clear structure and you can get a lot of credit, hopefully all the credit, by just setting up the structure. And then sometimes we do ask, I mean, I would say that it's about, maybe the last 4 exams aren't a good example, but usually we kind of flip a coin between these two topics. So be ready for both. Don't just assume because you haven't, whatever. Know them both. So an applied problem is going to say something. It's going to say maximize the volume or minimize the area, whatever it is. If it says maximize volume and it has to do with a box, the first thing you're going to do is this, and then you're trying to replace the Z with a constraint. If it says minimize the surface area, the first thing you're going to do is you're going to list the surface area, and then you're going to replace Z with the constraint. Once you've replaced Z, you're going to have a 2-variable function, and the rest of the problem becomes find the critical point. That's what those questions are. Okay, so that's something you know is coming. That's the middle piece of this, pages 3 and 4 of the exam. There's a quick recap. And now if you were to look at old finals and just click on some random ones, this is some going further back and I have not picked. So the first questions are about lines and planes. Then we have a question about curves. And then we have a question about polar. So technically that's from before we switched the topic. But here we go. We finally have a question. This is about partial derivatives. This is about tangent plane with implicit. That's a volume question. Let's see if I can find some other one. Okay, that's about a curve. So it looks like used to be we didn't always have these in the same order. Find all points in the plane that gives a local minimum on that plane. Then do the second derivative test. So this is an applied max and min question. This one looks a little funny, but it says find all points that give a local minimum. So you're trying to replace the Z right here with this. That gives a 2-variable function, and then you're going to find a critical point. Okay, let's leave that and I'll move on to chapter 15.